Alright. Can you hear a lot of noise in the background?
Yeah.
Yeah, sorry.
Yeah. Yeah.
Yeah, could you turn it down?
That's okay.
Alright. We're watching X-Men, so, I'm not. He is, though.
At least something good to listen to.
Yeah. Exactly.
Um. So, do you have any questions about the prep assignment?
Yes. I have a few.
Okay.
The number 4. Like, I think I got that one right, but just wanted to make sure.
The condition required to build the +4 confidence interval.
Yeah. So
It's just the n has to be greater than or equal to 5.
Okay. Yeah. I got that one. Okay. Just wanted to make sure. And then the formula is that it kind of looks like the z-score formula, except it's p tilde plus minus z or something like that. It's just a big long equation.
Yeah, it's pretty much the same thing, only you use the p tilde, and instead of it just being n underneath the square root that they divide by, it's n plus 4.
Okay. Okay, cool.
Other than that, it's pretty normal.
Yeah. Alright. Sweet. Yeah, okay, got it. And the number 6, that one was kind of weird for me.
Oh, the test statistic formula?
Yeah.
It's the same thing that was from the last one, too. It's z equals p hat minus p divided by the square root of p times 1 minus p divided by n.
Oh, that's it? No.
Yeah, it's the same one as last time.
Oh, okay. It's p hat, okay. Same one as last time. Alright. Alright. Yeah, I think that might be it.
Okay. Did you already do part 2 or not yet?
Not yet. No.
Not yet, okay. Well, let's go ahead and go over it then.
Sweet.
So, find the proportion of those who have been in an automobile accident in the last 5 years. Wouldn't that just be the 684 divided by 1006?
Yeah, I think so.
So that should be 0.6799. That's what I got.
0.6759. That into
0.6799.
Oh, 99. Okay.
Yeah.
Okay, yeah, that's what I got too. 99.
And the requirements are definitely met because n is 1006. It's definitely bigger than 5.
Yeah. Okay, and then the margin of error for a 95% confidence interval based on these, or determine the margin of error for a 95% confidence interval based on these data.
So to get the 95% confidence interval z-score, you go to the probability applet, and it should give you like 1.96.
Oh, darn. Hold on. I forgot to pull it up. Okay, I got it.
Okay. And then you just take the 1.96, and then you just multiply that times the square root of p times minus p divided by n.
Okay, multiply that square root of p.
Yeah, of p, the one that you found in the first problem was like the
6799. Okay.
Yeah.
0.6 times. Alright, it comes out to like 1.33.
No.
Oh no, just kidding.
Did you get the, because it's the 0.6799 times 1 minus 0.6799 divided by 1006, and that's all under the square root.
Oh, right, okay. Okay, so 1.96 times 0.6799. And okay, got it. Okay. Okay.
What'd you get?
Yeah, so sorry, I'm still putting in the numbers. 6 over. Yeah, so is the sample n, is it n plus 4, so it's like 1006 plus 4?
No, this one's not the P. Yeah, this one's not the confidence interval for. We're not on the confidence interval. It's just the margin of error.
Okay. Makes sense. Six. Okay. Okay, hold on. I don't know if I'm getting the right numbers. Okay, so let me just walk through it again. So the equation I should be putting in is 1.96 times 0.6799. Correct so far?
No,
No?
it's 1.96 times the square root of 0.6799 times 1 minus 0.6799 divided by 1006.
Okay. So square root of 0.6799 multiplied by
Times 1, yeah, 1 minus 0.6799.
Okay. Okay. I'm not.
What'd you get?
Nothing. It's not even like my calculator's not even able to compute it. Like, yeah. Okay.
You
Yeah,
could do
I have no
probably the
idea.
step. You could probably, instead of trying to put it all in at one time, do this 0.6799 times 1 minus 0.6799,
Right.
and then get that answer. Divide that by 1006.
All right. So 0.6799
And then once you divide that by
times
1000 times
okay.
1 minus 0.6799.
Okay. Times 1 minus 1.96.
1 minus 0.6799. You use the same number twice.
Oh, the same number twice. Okay. Okay, I just get 0 with that. 0.6799 times 1
1 minus 0.6799.
0.6799. All right, and I get 0. Am I supposed to put that in parentheses or?
I would put the 1 minus 0.6799 in parentheses.
Okay. All right, so I get 0.217 or 218.
Yep.
Okay.
And then take that answer and divide that by 1006.
6. Okay.
And then you're going to square root the answer you get from that one.
Okay. Okay.
And then you're going to multiply that answer by 1.96.
All right. So I got 0.0288.
Yep, that's the answer.
Okay. Cool. Thanks.
Yeah, no problem. If your calculator's not doing the whole equation, just break it up into little pieces like that, and it should help.
Okay. Yeah. That should help. All right. So B now.
Yep. We're on D, yeah.
Okay. All right. So construct and interpret the 95% confidence interval for the proportion of those who have been involved and not people.
So you should have the confidence interval formula from part 1.
Mm-hmm.
And so you're literally just filling in those numbers, except for the p tilde. You actually have to calculate that, which is not hard.
Uh-huh.
You just take your x plus 2 and divide that by your n plus 4.
Okay. X plus 2. So. So that. Let's see. the confidence interval is that 0.6799 or
The confidence interval, that's
yeah,
when you use
so I have p tilde
of 0.6792, right?
Yeah, that's what I got.
Okay, yeah, you use that,
Uh-huh.
and basically you're plugging it into the margin of error formula.
Okay.
The only difference is that it's the p tilde plus or minus the formula, and in the formula, instead of it just being divided by n, it's divided by n plus 4.
Okay. All right. So
Like, do everything under the square root again, and then square root it, multiply it by 1.96, and then add and subtract it from 0.6792.
okay.
Or I have a way easier way for you to do this.
Okay.
So you take the 0.6792 you found for p tilde, and you take the margin of error, and you add and subtract the margin of error from your p tilde.
Okay.
And that gives you your confidence interval.
Okay. And the margin. Oh, it's just okay. Okay, so subtract the margin of error from the p tilde.
Yeah.
Oh, okay. Yeah, I got like 0.6503.
0.6504, right?
I got 0.6503, but I don't know.
Because it's 0.6792 minus 0.0288.
Reach out again. 6792 minus. Yeah, it's just my calculator or something. Maybe it just computes it different because I'm getting the same thing. 792, but
Are you doing minus 0.0288 or minus 0.029?
yeah, I'm doing 0.0288.
Oh, okay.
Yeah. Yeah. So let's try that again. Yes. Yeah. Okay. I got it.
Yep, and then you add the 0.0288 to 0.6792, and you should get 0.708.
Okay. So add. I'm sorry. So add point. Wait, I add what to it?
The margin of error, the 0.0288, because you add and
0.02.
subtract it from
Okay.
the p tilde.
88. Okay, then. Okay, and then after that,
That should be the two numbers you have.
just. Okay. All right. Oh, so because this is the
Confidence interval.
confidence interval. Okay, so there should be two numbers.
Yeah.
Okay. Okay. then E, right?
Yep.
Okay. College students should just survey if you want 95% confidence interval, margin of error no more than 0.015. So it's asking for a okay. So if we want the margin of error to be smaller, we interview more people.
Yeah.
Okay. Okay.
And the formula is just z-score divided by 2 times the margin of error you want. And then you can take that number and square it.
Okay. This is that.
That's dumb. He's looking a little bit right. Where do you register it?
The formula is that.
Let's
see.
That's your, in parentheses, z-score divided by
Cool.
So trying to,
times the margin of error.
this is the z-score formula?
No. This is the, to find the number of, like, to find your number.
Right.
The sample size.
Right.
So it'd be n equals, parenthesis, z-score divided by 2m, close parenthesis, and square it.
Oh, okay.
No, they. Yes. Yeah. That's the motion in there.
Yes.
Right?
And
I'm so excited. I know. Okay, that's cool. So get excited. We have 4 weeks this Monday. 4 weeks left this Monday. There's so many finals. No. So glad about it. I just remember saying we had 7 weeks. And now we're down to 4 weeks. Oh yeah, that's right. Really? Dirt. Should we have 1? We got 2 weeks this Friday, tomorrow. Then we have 3. Oh, this is up to next class today. From 8 to 6. From 8 to 9. What?
Red class?
Self defense.
Red?
What that is?
okay. Okay. So I got
Sure.
like some crazy big number, 4,631.
I got 4,268 point like 33333, and so that should round up to 4,269.
Okay.
You were close though, because you got something in the 4,000s. So what
Yeah.
exactly did you type in?
All right. So the z-score, that's still using
1.96.
1.96. So yeah, okay. So I did that. So I did.
Yeah.
Wait, crap. Let me go back. Okay, so 1.96 over. Oh wait, maybe that. Okay. I'm supposed to multiply the margin of error by 2, right?
Yeah.
Oh, yeah. Okay, I didn't do that. Do that again. Okay, now I'm not even getting close to 4,000. 96 over.
So it should be 0.196 divided by technically
What?
0.03. 2 times
1.96?
1.96
1.96, and then
divided, and you divide that by 2 times the margin of error,
yeah,
which would be 0.03.
0.03. Okay. All right.
Yeah, because you double 0.15, 0.015, and it should be 0.03.
Okay.
And that should give you like 65.33333333.
Okay.
And then once you get that, you just square it.
Okay.
It's possible to rent
6
your guys'
for
seasonal
2
party.
times 0.03.
No. It's not 2 times 0.03. 2 times 0.015 is 0.03.
Perfect.
Okay.
Okay, bye.
Okay. So 0.03. Square that. Okay. 1.96 divided by 0.03. Is that 0.03? Okay. All right. I'm getting closer now.
And so that should be like 65, and then you square that for 4,268.44444.
Okay. Okay, yeah, I got it.
Okay.
All right.
All right, so then you move on to the hypothesis test stuff.
Mhm.
Now you're interested in testing a claim that is over 60% of all students have been in a car accident within the last 5 years. Same information as the last question, with a significance of 0.05. So the null and alternative hypotheses should be E should equal 0.6. Yeah.
Should equal 0.6?
P would equal 0.6 for the null, and the alternative is that P is greater than 0.6.
Okay. Six. Okay, yeah, makes sense. And the test statistic would just
Yeah,
be
that's the same thing we calculated last time.
yeah. Okay.
Well, not the same thing, but it's like the same formula we used last time, so it shouldn't be too difficult.
All right. So okay, so which formula would that be for the test statistic?
It's Z equals P hat minus P divided by the square root of P times 1 minus P divided by N.
Oh, okay.
It's the one that you asked me about, was like number 6 or something.
Okay.
Yeah, it's number 6 from part 1.
Okay. Statistic. Hold on, give me 1 second. Okay, so I think I accidentally deleted the. I wrote down the test statistic equation like on my computer, but I accidentally deleted it.
Okay,
So which
it's
one?
P hat minus P
Minus P.
divided by
Okay.
the square root of P times 1 minus P,
1 minus P. Okay.
and 1 minus P is in parentheses.
Yeah.
And you divide P, you divide that stuff by N inside the square root still.
And without the plus 4.
Yes.
Okay. Okay. All right.
The +4 only goes for the confidence interval.
Okay. P hat. Minus. All right, so would it be 0.6 minus 0.6799, or is it the other way around?
The other way around, because
Other
P
way
hat is 0.6799.
Okay. 0.6. 6. 6. And is N would be 1006, right?
Yeah.
Okay. All right, figure this out. Okay, so I got 5.17.
Yeah, it should be like 5.17, 5.173, something like that.
3. Okay, yeah, that's what I got.
And then you just take the test statistic and you plug it into your normal probability app.
Okay.
But make sure, since P has to be greater than 0.6, it's only on the plus side of the thing.
Okay. Okay. So, right. Okay, so it'd be 0.0250 for the.
I got like 1.1518 times 10 to the negative 7.
Wait, hold on. Sorry. It like changed the number in the Z-score box, so sorry. 5.173. So what did you get again?
Like 1.15 times 10 to the negative 7.
Yeah. Okay, I got that.
And so basically you find that number and then you compare it to see if it'd be bigger or less than the level of significance and whether you fail or reject the null.
Okay. And that's bigger. It's way bigger than. No, that's smaller than 0.05, isn't it?
Yes, that's way smaller than
Way
0.05.
smaller. Okay, yeah. Yeah, so you would reject it.
Yep.
Alright. Sweet. Okay. So to state your conclusions would just be the null hypothesis is right. So yeah.
It's just saying that basically, more than likely, your alternative hypothesis is correct. So there's statistical evidence that more than 60% of students have been in a car accident within the last 5 years.
Got it. All right, cool. Oof.
All right.
I think I get it a little more. A lot of stuff, but
Yeah.
Get a little more. Sweet. So we'll just go to the group quiz.
Yep.
All right, cool. Okay, I'm in.
All right. So, number 3 then. The symbol for the true population proportion is, that should be p hat.
P hat?
I'm pretty sure.
Yeah, I'm looking at the reading right now just to make sure.
It was in like the second paragraph in the first section.
Yeah. True population proportion. Wait. Okay, so the reason the study was conducted is an estimate of the true population proportion P. So the question's asking.
Well, what is p hat then? Is that just the estimator?
It is the P hat is called a point estimate of P.
That's right.
Okay.
Okay. So it's p, not p hat for number 3.
Okay. Questions 4 and 5. Suppose n equals 20, p equals 1/4. So the requirements for constructing a confidence interval
Are satisfied? True, because n is greater than 5.
Okay.
Requirements for testing a hypothesis test are satisfied. The requirements are that n times p has to be greater than 10, which is not true.
Oh.
And n times, or hold on. And then, yeah, n times p has to be greater than or equal to 10, and then n times 1 minus p has to be greater than or equal to 10.
Okay, so the n has to be equal to 10. Or greater.
Yeah, they both have to be greater than or equal to 10, and 20 times 1/4 is only 5, so that's false. The requirements are not met.
Okay. Study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. This is information for questions 6 through 9. So P tilde plus 4 estimated the proportion of first-degree murder defendants who were found guilty in this state.
So that would be 45 plus 2 divided by 60 plus 4.
Okay. 47 over 64. So, 0.734.
Mm-hmm.
hat. So p hat would just be 45 over 60, right?
Yeah.
Okay. Cool. So I got 0.75.
Yeah, that's what I got too.
All right, cool. So 8. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state where the verdict is guilty. So, that. Sample size 60. Oh, dang it. Wait, I think I did that wrong. For this one, we're supposed to do the p tilde minus the z-score, right?
Yeah.
Oh, shoot. I did the wrong one. Okay. Shoot. So run me through the z-score formula. I just blanked.
The z-score formula?
Is that because we have to find the z-score for?
Oh, the z-score is just 1.96 because it's a 95% confidence interval.
Yeah. Okay. Sorry, I thought we were supposed to calculate that. All right. So. That's where that comes. We have to do it. Okay, minus.
Did you get it?
Almost there.
Okay.
Okay, I must have done something wrong. I'm not getting it. I got. Yeah. Got some crazy number.
What'd you get?
Negative 22.
Yeah, no.
Nope.
Okay. I can read you exactly what I put in for my formula and see if maybe something was in yours was off.
Okay. Sounds good.
Okay, so mine was 0.734
Mm-hmm.
plus or minus 1.96
Okay.
times the square root of 0.734
Okay.
parentheses 1 minus 0.734 close parentheses divided by 60 plus 4.
Okay. I have all those numbers in. I just must just put it in wrong. Um, so that's 3, 4. Let me try it again. So what did you get? I got. Wait, hold on. Wait. Just kidding. Okay. What the heck? All right. All right. I have all the numbers in the equation that are correct, but
It's still not showing up?
it's just not. Yeah, it's just not happening. Trying to break it up as much as I can.
I say if it helps, the lower number I got was
Uh-huh.
0.626.
626. Okay.
Yeah.
Uh, uh, 0.73. What the heck? Well, I don't know. I don't know what I'm doing. Just keep getting the same numbers. Let's go over and over again. Okay, so maybe so the p tilde, the first part of the equation, so it's p tilde with the z-score of 1.96. Do you multiply those two, or
You add and subtract.
you
So
add?
for one, yeah, it's plus or minus between the two of those.
Okay.
Because you're going to add it together one time and you're going to subtract it the other time to give you the confidence interval.
Okay. Let's see. Do you want to just skip this one because it's just not coming. Just come back to
Yeah, that's fine.
All right.
Okay, so if you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? I'm pretty sure that the larger the sample size, the smaller the confidence interval.
Yeah.
So I'm pretty sure it decreases.
Yeah.
And then to conduct a hypothesis test for one proportion, two requirements must be met. Suppose that p equals 1/2. What is the smallest n can be and both requirements still be met? So instead of solving for n this time, because they don't give us a margin of error, normally you would just say, well, n times p has to be greater than or equal to 10. So what times 1/2 would be greater than or equal to 10? So that would be 20.
20. Yeah.
And you check that with n. So and then you could check that with the n times 1 minus p, and that would still give you the right answer.
Right.
And then it's the same thing for number 11, only instead of it being 1/2, it's 1/10. So
Yeah.
the number I got was 100.
100. Yeah. Yeah. All right. Okay. So for questions 12 through 17, use the following information. For the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. Researchers suspect that water quality in the area has decreased. We conduct a hypothesis test using significance level of 0.05 with the following hypotheses. The null hypothesis is that the probability is equal to 0.6, and the alternative hypothesis is that it's lower than 0.6. They collect new data, and this time n equals 80 and x equals 38. That indicates good health. Conditions for conducting a hypothesis test are satisfied, true or false.
I would say true, because if you were to do 80 times 0.6,
yeah,
that gives you like 32.
80
or
times
42.
0.6?
Hold on.
Like
It gives you like 48.
Yeah.
I was thinking of, I'm not even sure. Oh, 8 times 4. Just kidding. That's what I was thinking of.
All right.
And so that should give you 48. So that would satisfy the first one. And then if you were to do 80 times 1 minus 0.6, it's like, I think that one's 32. And so that would both meet the requirements for the hypothesis test.
Right. This is true. Number 12 is true. All right. So p hat. Yeah. So 13, the p hat is 0.475.
Yep.
Statistic, just 1.96 is the z-score.
Z-score? Yeah, but you don't need the z-score for the test statistic.
Okay. Right.
Hi.
So you need the probability output for that, or
Not for the test statistic.
wait? Okay.
Because the test statistic is your p hat minus p divided by p times 1 minus p over n.
Okay. So p. It's just p, not p hat, or is it p hat?
Well, it's p hat minus p
Okay.
to find the test statistic. and then under the under the square root, it's just p. So it'd be p times 1 minus p divided by n.
Okay. So the p hat's 0.475. So would p just be 60%, like 0.6?
Yeah.
Or is it? Yeah, it is. Okay. Just making sure. Divided by n. So that would be 80. Okay, so for the equation that you wrote down, this is what I've written down. So I have 0.475 minus 0.6, right? And then
Yes.
divided by the square root of 0.6 times 1 minus 0.6 over 80.
Yes.
Right? Okay. All right. So what am I doing wrong?
Where do you have your parentheses at when you type it in?
Over 1 minus 0.6.
Then you have 0.6 times the 1 minus 0.6 before you divide that by 80, right?
Before I divide it by 80.
Because if not, it'll be because otherwise it'll just be the 1 minus 0.6 divided by 80 times 0.6.
Right. Yeah. So I could do it again just to make sure. Okay, so I get 0.24, and then you divide that by 80. And then I get 0.003
No, Tiffany?
No, Tiffany.
on that side. And do I square root the 0.003?
Because I had her for the longest time.
I know.
And was
Yes.
we had a
Okay.
truce. I just wasn't gonna kill her.
I know. The last time I heard you, I was watching a movie and I heard you laugh. I was like, and so I was like,
And then I get some crazy number like 0.05477.
Yeah. And then you're going to take that number,
Yeah.
and that's going to be, you're going to take the 0.475
Eventually, I
minus,
would. I hate you have these cutters.
and you're going to divide that by the answer you just got.
Okay.
I was going to come in.
So
Freddie was already
0.475 minus 0.6, that's like
I thought it was weird
Oh.
that he was standing outside. That's why I had
Yeah.
Tiffany look outside. I was like, why is Brady out there?
I got negative
He looked like he was on the phone. He
0.125
He didn't just like sit here and look
divided
for
by
He did his best.
7226. Oh,
Yeah,
okay.
she's not here.
Now I get the right answer, I think.
What?
You know how much research.
What'd you get?
Negative 2.28.
I don't know where she is.
Yep.
Oh, okay, awesome.
I came over here for
Awesome.
Now you take it to the probability after to find the p-value.
Yeah.
You got the rounds.
Oh, cool. I didn't even care.
You better.
All it took was making sure Tiffany did all the dirty work.
Smaller than possible. So you want the left extreme end. So you want highlighted.
Yes.
Okay. So I get 0.0113.
Yep.
Alright.
But just make sure, because you round it to 3 decimals, it's just 0.011.
Okay.
Well, no, she has a price.
Alright, cool.
Yeah.
Trust lost.
P-value for this
We were all
test.
on the truth. Like, our entire apartment was on the truth.
Everyone was all like walking in the park.
We all wanted Tiffany to win. That's why we were all helping her.
Probably still want
I don't care anymore. She'll probably be over here tonight. That half of my food in the bottom of yours.
This is mine. I sat on this one.
Oh.
The top half says like red lobby and alright.
And the p-value, is that's not in the probability applet, right?
The p-value, you already found the p-value, is 0.011.
So it's the same answer as 14?
No, 14 is negative 2.282. Because that's your z-score.
Okay. Alright. Okay. 2.28. Okay. 2.2. You said?
Yeah, negative 2.282.
Okay. I got both of them. So should we reject the null hypothesis, right?
Uh-huh.
Okay. So L17. So which of the following best summarizes the conclusion of this test? There's sufficient evidence to conclude that water quality area has decreased. So there's sufficient evidence to decreased. So would it be the third choice? There's sufficient evidence to conclude that water quality in the area has increased.
Nope, there's sufficient evidence to conclude that the water in the area has decreased.
Okay, yeah, because it's smaller than. Oh, got it. Yeah, I just got that mixed up. Okay. All right, cool. I think that's. Oh wait, hold on. There's one more. Number 8. Yeah.
That was the 0.626 to 0.842, right?
Yeah. Or 4.3. Yeah, that's what it says.
Well, 0.843. I rounded wrong.
Yeah, no, you're good. Yeah. Let's go with that.
Okay.
Cool. I'm gonna submit. All right, cool.
100.
Yes. What a relief. Awesome. Oh, cool. Thanks for your help.
All right.
Yeah, really appreciate it.
Yeah, no problem. If you get stuck on any more of the problems while you're doing homework, just shoot me an email and I'll send back to you whatever I got or
Sweet.
however I figured it out. So you can see it.
Yeah, that sounds good. We'll do that.